Hello students, I Professor Jigisa. In this video, I am going to explain you what is the clipper circuit and how to solve clipper circuit example. So first, what is the clipper circuit? If you want to remove or cut positive half cycle of the input signal, negative half cycle of the input signal, or both positive and negative half cycle of the input signal, at a time we are using a clipper circuit. So clipper circuit is used to cut or remove unwanted portion of the signal. So the application of the clipper circuit is amplitude limiting and noise eliminating. Now take one example. If we want to pass this signal through the channel, after passing through the channel, the signal is become noisy. It's look like this. So if we want to remove or cut this portion and noisy part, we are using clipper circuit. So this is the classification of the clipper circuit. There is two type of the clipper circuit: series clipper circuit and parallel clipper circuit, or we can say that parallel clipper circuit as a shunt clipper circuit. So series clipper circuit is divided into two parts. It is unbiased positive and biased negative, and bias positive clipper circuit and bias negative clipper circuit. Then shunt clipper circuit is also divided into two parts. It is unbiased positive and bias unbiased negative, and bias positive and bias negative. Before going to the example, we will see that which part will be clipped. For finding out which part will be clipped, we have to see the arrow of the diode. If the arrow of the diode, this arrow of the diode is going to the upward side, or arrow of the diode is going to the right hand side, we can say that negative part will be clipped, but it is with respect to the reference voltage. This is the reference voltage. And if arrow of the diode is going to the downward side, or arrow of the diode is going to the left hand side, we can say that the positive part will be clipped, but it is with respect to battery, this reference voltage. And another method is, we have to take a reference point here, reference point A, and from this reference point the diode first negative terminal is come first, so we can say that negative part will be clipped. Here if the reference point A, reference point 2, diode positive part will become first, so we can say that positive part will be clipped. Now for finding out when the diode is in reverse bias or in a forward bias, if series connection is there, at clipping time diode is remain off condition, means it is in reverse bias. For parallel connection, clipping time diode is in forward bias. So these two rules we have to see. For example, now we are starting to solve circuit for the series clipper. Now how can we say that it is a series clipper? If the diode is connected with the input voltage in series, or diode is connected with the resistor in series, then we can say that it is a series connection. Now this is the input signal. First we will check the arrow of the diode. Here arrow of the diode is going to the left hand side, or at the reference point A, this is the terminal of the input voltage. So we have to take a reference point here. At the reference point A, diode positive part is come first. So we can say that positive cycle will be clipped. So here the output voltage is like this. So how to write? So first we have to write for the first positive half cycle. First positive half cycle, what happened? In a series connection, clipping time diode is in reverse bias. This is our second rule. See, the series connection, clipping time diode is in reverse bias, means it is remains off. So here diode is in reverse bias, so it is in off condition. It is replaced by open circuit. So output voltage which is equal to 0, and here output voltage which is equal to V in. So for the first positive half cycle, diode is in reverse bias, it is replaced by open circuit. And what is the output voltage? Output voltage which is equal to 0. And for the negative half cycle means this cycles, what is the output voltage? Diode is in forward bias. Diode is in forward bias. It is replaced by short circuit and output voltage which is equal to VE. Okay. Now for this circuit, the arrow of the diode is going to the right hand side, and for this for this reference point, the diode negative part will become first. So we can say that negative part will be clipped. So here the output voltage is like this. And in a series connection, at clipping time, this is the clipping time. At that time diode is in reverse bias, and here diode is in forward bias. So what is the output voltage here? Output voltage which is equal to V in for this positive half cycle, and output voltage for the negative half cycle, it is become a 0. Here negative part will be clipped, so it is called that the series negative clipper circuit. Here the positive part will be clipped, so it is called that the series positive clipper circuit. Now series bias positive clipper circuit. Now there is the one word is bias. Biasing means we have to connect the circuit with the external voltage supply. This is the reference voltage which is VVB. So it is called as a biasing condition. Now diode is connected with the input voltage and resistor in series, so it is a series connection is there. Now first find it out which part will be clipped. The arrow of the diode is going to the left hand side, and this reference point to diode first terminal is positive, so positive part will be clipped. Now positive part will be clipped, but it is with respect to reference voltage. Here reference voltage is VB. So after VB, this is first find it out which battery is there. It is positive or negative. If the negative terminal of the battery is connected with the ground, so we can say that it is a positive battery. So positive battery is come here VB. Positive part will be clipped with respect to positive battery. So this part will be clipped. So we will get this much output. Now in a series connection, clipping time diode is in reverse bias. So this is our clipping time. At that time diode is in reverse bias. So what is the output voltage? Output voltage which is equal to VB or VR, reference voltage, right? And here non-clipping time. At that time diode is in forward bias, and output voltage which is equal to VE. If diode is in forward bias, it is replaced by short circuit and output voltage which is equal to VE, right? Now in the first positive half cycle, it is divided into two parts. For this positive half cycle, it is divided into two parts. This part is V in which is less than VR, and this part is V in which is greater than VR. So what happened in V in less than VR and V in greater than VR? We have a two case, right? So in the first case, V in less than VR, at that time what is the output voltage? V output which is equal to V in. There is no part will be clipped, so we can say that diode is in forward bias and output voltage which is equal to V in. Here when V in is greater than VR, at that time clipping part is there. So at the clipping time diode is in reverse bias, and the output voltage which is equal to, what is the output voltage? VR. So output voltage which is equal to VR. In this case output voltage which is equal to VR, and this negative half cycle diode is in reverse bias and output voltage which is equal to, and the negative half cycle output voltage which is equal to VE this time period. Okay, output voltage which is equal to VE. Diode is in forward bias. So this is a series connection is that, so it is called as a series. Bias means external voltage we had supply with the diode, so it is bias, and the positive part will be clipped, so it is called as a, this positive part will be clipped, so it is called as a series bias positive clipper circuit. Now, series positive clipper circuit with negative bias. This is the positive battery we have connected with the diode. Here, negative, we have to connect the negative bias. We have to give a negative battery to the circuit. So, how it is negative? The positive terminal which is connected with the ground. This is the ground, so it is called as a negative battery. So first find it out which part will be clipped. Take a reference point A is here. A2 first diode positive terminal is come first. So we can say that positive part will be clipped and arrow of the diode is going to the left hand side. So we can say that the positive part will be clipped. Right? Now for this input cycle, what is the battery? Battery is negative, so battery is come at that. We have to place battery here VB. Now positive cycle we have to clip with respect to battery. So this part will be cut. So we will get this much output. So we can write this is the clipping time. So at the clipping time in the series circuit, diode is in reverse bias. And what is the output voltage? Output voltage is equal to minus VB, but it is same like voltage, reference voltage. And here diode is in forward bias. And what is the output voltage? Output voltage which is equal to VE, or we can say that VM minus VM. Okay. Now positive part will be clipped, so it is called as a series positive clipper with negative biasing, negative reference voltage. Now series bias negative clipper circuit. First find it out which part we have to clip. So at the reference point A to negative part of the diode is come first, so negative part will be clipped, and the battery is positive or negative. For find it out that negative is connected with the ground, so battery is a positive. So positive battery we have to place VB here. So negative part will be clipped after reference voltage, this part will be clipped, so we will get this is the output. At the clipping time, this is the clipping time, these two are the clipping time. At the time diode is in off condition, means it is in reverse bias, output voltage which is equal to VB. And here non-clipping time, diode is in forward bias and the output voltage which is same is equal to VE. It is easy. Now for this circuit, for the reference point A2, diode negative terminal is come first, negative part will be clipped, and diode is going to the right hand side, arrow of the diode is going to the right hand side, so negative part will be clipped. And this is the negative battery because positive part of the battery which is connected with the ground, so it is a negative batteries, negative reference voltage. So negative reference voltage is connected to negative cycle. After the negatives with respect to this reference voltage, negative part will we have to clip. So this much part it will be clipped. For positive half cycle, it is non-clipping time. Diode is in forward bias. At the time output voltage which is equal to V in, and here there is a two condition for the negative half cycle. If Vin is less than VB and Vin is greater than VB, there are two cases. For the clipping time, at that time diode is in reverse bias and the output voltage which is equal to VB, and here the output voltage which is equal to VE. So in the next lecture we will see shunt clipper circuit.